Good morning. I'd like to take the next few minutes to tell you about a major new global initiative, a $100 million initiative to dramatically accelerate the development of artificial intelligence in children's medicine. But before I start that, let me start with a story. This is actually a story Dr. Anthony Chang tells about a little girl in Myanmar who he was providing consulting services for. They wanted to be able to share the echo with him. They couldn't get it to him. In the end, the little girl died on an operating room table. And later on, Anthony got to see it. And he said, oh, I could have easily told them what to do. So the question for this community is, why couldn't Anthony's brain have been in Myanmar? Why couldn't we have done that? AI, as we know, holds the key to revolutionizing healthcare for the kids of the world. And frankly, whether that's in Myanmar or Montana or any rural area in the world. I think there's three big challenges to developing AI for kids. I want to talk about all three. The first is a technical infrastructure. I'm going to highlight some of the challenges there and an interesting new approach. Number two, there is the challenge of educating multidisciplinary teams, whether that's clinicians or AI developers. And the third, and we're going to end there, is to talk about funding. How do we pay for doing this? So let's start with the technology infrastructure. I think everybody in AI knows or has seen this chart, which basically argues that we know that the more data you have, the more accuracy you can create in an AI algorithm. But the lack of diverse data sets is holding up progress. This is from a conference last year at Texas Children's, and we've seen these kind of slides over and over again. And by the way, the EU just issued a report on the state of the art in AI in medicine, and the single technical recommendation they made was we must figure out how to enable access to healthcare data. So when we talk about the data, where is the data? Well, I'm going to say to you, it's not in the EMR and the EHR. Where is it? It's in the millions of healthcare machines around the world, whether that's an ultrasound, a blood analyzer, a gene sequencer, a drug infusion pump. It's in the millions of machines in the world. But I want you to stop and think about the current approach is really, let's go try to aggregate this data in some central repository. But I'm going to tell you, I think this is exactly the wrong thing to do for two fundamental reasons. One, I'm going to call it schema locked in. Central repositories, if you go build them, beg for a schema. And unfortunately, we in enterprise software have seen the challenges of having locked in schemas. The ability to share data between an SAP application and Oracle application is nearly impossible because the schemas were locked by an application. So if you go create a central repository and create a schema for it, the next application is going to have a very difficult time using it. The second reason central repositories won't work is it violates the fundamental principles of privacy. Trying to aggregate a bunch of data and then telling people, well, I don't really know what I'm going to do with it, I just want you to trust me, is not the approach. The fundamentals of privacy dictate that you have purpose limitation, data minimization, and storage limitations. And that is exactly the opposite of a central repository. Central repositories also lead to where we are today in AI, which is, I'm going to call it batch learning. So we get a bunch of data, we go learn on it, et cetera, and we create the ROC curves. And one day we go, yep, it's good. We're ready to go. But the question we're left with at some point in time is, well, when do we relearn? How do we know how far the algorithms have drifted? And I just want to highlight that, none of us as humans learn in batch. So I think there needs to be a new technical infrastructure architecture, one that has the ability to standardize the data from any healthcare machine in the world. Number two, to enable application-specific data access. So just like on your phone, you get to say, well, Facebook can see my photos, but not my location, and Twitter can see my location, but not my photos. we have to move to the same model with respect to healthcare data, make this for a particular purpose, for a particular application. Third, we need to figure out how to learn with privacy, and the infrastructure must support a federated, and by the way, by going to a federated learning model, we can also move to a continuous learning model. So those challenges of relearning and drift, et cetera, will be a thing of the past. We need to think in terms of continuous learning. And finally, why build an architecture where you can't deploy the application to the point of care? So we've actually at Bevel Cloud developed a new technology we refer to as an edge cloud. There have been a series of AI applications that have been developed for this. I could go into way more detail about all the different specifics of this, but I want to let you think that we've cracked through a lot of the problems of how such a infrastructure could work. And the clinical community has really gravitated to this vision. This is a quote from Ian Hennessy, and he basically says, what if we could create a network of not just people, but the equipment and the data systems, how that would change children's healthcare. And our own Dr. Anthony Chang has coined the term a pediatric internet and talked about it being very similar to our brains, our nervous systems, and the implication on the kids of the world. Since he used the phrase pediatric internet, I just want to give you a quick glimpse. We, just like the original internet, we will end our first year with 4 nodes, 4 edge zones. I'm giving you an idea of where those edge zones are. And in 2022, we have set ourselves a goal that we're going to have 64 edge zones, including, and there already have been conversations in Africa and in Australia, because I think we need to think about this as a global initiative. So enough about technology. Let's get to the second big challenge, which is who's going to build these AI applications? Well, we're going to have to educate multidisciplinary teams. And I'm going to conjecture that this education must be bidirectional. So I know Anthony's done a lot of work in AI Med to help the medical professionals begin to understand words like CNN and federated learning and ROC curves. But I think we also need the other, which is how do we take the AI community and get them educated on the basic vocabularies of medicine. And I just like to highlight that one of the 4 EU goals has been how do we upscale healthcare professionals and educate AI developers on current clinical practices. Which brings me to the third point, which is funding. How are we going to give clinicians, give AI developers the time and resource to be able to do this, to be able to build AI algorithms in cardiology, radiology, endocrinology, et cetera. And I'll tell you, it's not going to happen because there's funding from NIH. We've actually done a study of the $40+ billion spent by NIH. Only $2 billion is spent on kids, and out of that $2 billion, 0 is spent on AI. And while my VC friends are very generous in many different ways, the idea of funding children's software, children's AI, AI4Kids, that's not a big enough market. So what can we do? And I want to highlight something that maybe some of you have heard about. There has been a movement in the investment community referred to as ESG, stands for environmental, social, and governance. And it really talks to the fact that the investment community is interested in evaluating corporate contribution to the future of the environment, to the future of society. And it has begun in Europe, but it has become a guiding principle for investors around the world. I want to point out a quote from the BlackRock CEO, a big hedge fund, and he basically says, it is not just about financial performance, it's about how do we make a positive contribution to society. Just to make it a little bit more specific to you, these are Intel's 2030 ESG goals. They have 3 of them. One of them is, and this is a direct quote, is to lead in advancing wellness and revolutionize health and safety. If you took that quote and made it a little bit more specific and say, why doesn't Intel lead in advancing wellness for the kids of the world and revolutionizing health and safety for the kids of the world? Then I think you can start to realize that the corporations out there who want to participate in making their ESG goals could be interested in helping us launch what we are calling AI for Kids, a $100 million global initiative. The fundamental idea is that all 500 children's hospitals in the world will receive a $200,000 grant to fund the development of, the testing of, the learning about AI for Kids applications. It will be led by a clinician, what we're calling an AI Kids fellow from the hospital. And I just want to point out that in this whole idea, we are thinking that the funds will flow directly to the foundation. There is no intermediary in this. So I hope that you're inspired by this, that you want to contribute to this, that you can also imagine that if we can do this, no kid in the future has to suffer the fate of that little girl in Myanmar. So my ask to you is, will you join us? Will you join our initiative we're calling AI for Kids? Thank you.